Hey there, CJ Math students. So I'm going to finally make you a AIMSweb Level 2 reference video that you can consult when doing a Level 2 AIMSweb, since so many of you are on it. So fast forward to the problem that you need help on, or watch it in its entirety. Up to you. So problem number one is a one-step equation. What we do this is we need to isolate the variable x, and so how do we do that? We look at the operation and we say, okay, let's just do the opposite of that. So what's the opposite of a positive 14? It's a negative 14. So subtract 14 from both sides, or adding negative 14 to both sides basically cancels this stuff out. You get 0 here. You get nothing but x left here. So x is equal to 28 plus negative 14, or 28 minus 14, which is 14. And that makes sense, right? 14 plus 14 equals 28. Problem number 2 is an exponent problem. This really means 2 times 2, not because of that 2, but just because the base is 2. So 2 times itself twice. So we get 4. If I had like 3 to the 2, that would mean 3 times 3, not 3 times 2. Okay. Writing in lowest fractions, we have 60 and 16, or 16 over 60. So let's go ahead and divide both of those by their greatest common factor, which actually happens to be 4. In doing so, I get 4 over 15. Now, just real quickly, if you didn't know it was 4, you could do 2, and you would get 8 over 30, and then you would just do 2 again, and that's how you would get 4 over 15. So either way works for you. Number 4 is very similar to number 1. Again, what's the opposite of a positive 15? It's negative 15. So why am I adding negative 15? Because I want this to be 0. So 15 plus negative 15 is 0. And basically, why do I want that to be 0? Because I want x all by itself. So x is equal to 32 plus negative 15, or basically 32 minus 15, which is 17. And if you took your answer 17 and you plugged it back into the top here, 15 plus 17 is 32. So you know it's the right answer. Next row, you have 11 over 88. So this is simple. Divide by its greatest common factor, which is 11. You get 1 over 8. 3 to the 2, there it is. Really means 3 times 3, not 3 times 2. So that's 9. Negative 2 plus 16. This is a different sign. Subtract and keep the one that we have more. We have more positive, so 16 minus 2 is positive 14. Number 8 is exactly like 1 and 4. So we'll add negative 16 to both sides. In doing so, this becomes 0. Why do I want that to become 0? Because I want x all by itself. So I get x is equal to 27 plus negative 16, which is the same thing as 27 minus 16, which I get positive 11. And if you take this and plug it back in, 16 plus 11 is 27. So we know that's the right answer. Number 9, we can divide by 3. In doing so, I get 1 over 2. Number 10, this is a little bit interesting. It's different than 1, 4, and 8, but it's still a one-step equation. So first of all, let's change this to plus negative. So we have something plus a negative 2 will give us 30. So to find out, we do the opposite of negative 2, which is add 2 to both sides, add 2 to both sides. Why do I do that? Because I want this to be 0. Negative 2 plus positive 2 is 0. I'm left with x. So x is equal to 30 plus 2, which is 32. And that makes sense, because if I take 32 and I plug it in here, 32 plus negative 2, or 32 minus 2 as it was originally, gives me 30. All right, so we're solving for the missing variable by isolating. 17 squared, you can take your reference sheet out, find out what 17 times 17 is. Hopefully you have it memorized. It's 289. You should probably get all your squares memorized up to like 19 or 20. 15 over 18, we can divide by 3. And I get 5 over 6. This is just a straight up multiplication problem, so let's go ahead. 5 times 4 is 20. Carry the 2. 5 times 1 is 5 plus 2 is 7. 5 times 4 is 20. Remember to lay your egg and then go on again. So 2 times 4 is 8. Cross that out, you don't need it anymore. 2 times 1 is 2. 2 times 4 is 8. And now we can add. So we get 0. We get 15 here. So I will carry a 1 right there. We get 1 plus 0 is plus 2 is 3. And 2 plus 8 is 10. So 10,350. Number 14, I can divide by 5 on both sides. I get 1/3. Here again, straight multiplication. So 2 times 2 is 4. 2 times 2 is 4. 2 times 4 is 8. Lay an egg. 5 times 2 is 10. So carry a 1. 5 times 2 is 10 again. Plus 1 is 11. So carry a 1 again. And then 5 times 4 is 20. Plus 1 is 21. So let's add that up. We have 4, 4, 9, 1, 2, 21,920. And guys, you have every right to go ahead and after you solve this and show work, to use the calculator and check to see if you have the right answer. And if you don't, then you erase and you try again. I encourage that, right? There's no sense in doing a problem, having it wrong, and then leaving it wrong. Number 16, one-step equation. So again, we want to make this guy 0 because we want to have nothing but x. We want to find out, solve for what x is on that side. We're going to learn a little bit more about this later on in the year. So plus negative 24 plus negative 24. Why did I do negative 24? Because I want this to be 0. 24 plus its opposite, which is negative 24, is 0. So I got nothing but x is equal to 39 plus 24, which is the same thing as 39 minus 24, and I get 15. If I plug 15 in here and I get 15 plus 24, I will get 39. So I know it's my right answer. 6 plus negative 8, again, DSSM, different sign, subtract, keep the one that has more, so negative 2, not positive 2. This one's a little bit interesting. You can actually think of it as 16 minus what number gives me 1. Just like you could think of this one as what number plus 24 gives me 39. Hopefully 15 comes to mind right off the bat. If you wanted to learn how to do it mathematically, first of all, this is really kind of a two-step equation. That's negative 1x. So you would add negative 16, and I'd get negative 1x equals negative 15. That's what 1 plus negative 16 is. And then we want to, in all these cases, solve for x, not negative x or negative 1x. So I divide by negative 1, divide by negative 1. And that's how those cancel out. I get negative 15 divided by negative 1 is positive 15. So either way you think about it, you're going to get the right answer. But if you wanted to kind of figure out how mathematically to do it, to show work, that's the way to do it. This is a same signs add keep. So you get negative 10. And this is just 12 times 12, not 12 times 2. So you get 144. Right, backside. To do a improper fraction to a mixed number, you divide 3 into 17. 3 goes into 17 5 times with 2 left over. So that is your whole number, 5. This is your numerator, 2. And this is your denominator over 3. Okay, so the 5 came from right here. The 2 came from right here. And the 3 just kept the same, 5 2/3. Right? This is in the hundredth spot, so therefore we can write this as a fraction easily by just taking it as 31 over 100. Obviously, you always want to line up your decimals, so 1.5, and then fill in an empty space with a 0, add it straight up. You should get 6, 5, 2.56. So just remember to line up your decimals on that one. Again, 24 is in the hundredth spot, so we can just go ahead and, as a fraction, write it as 53 over 100. Nothing to simplify there. All right, 25 is a little bit long, but we can do it. We just have to remember to swoop our decimals in the end, and in the end we're going to have to swoop 5 times because I have 3 decimals in the first one and 2 decimals in the second number. So the first row is going to give me nothing but zeros. If you wanted to, you could just lay an egg and go to the next row, but I'm just going to show all the work. So laid my egg there, then 3 times 1 is 3, 3 times 0 is 0, 3 times 2 is 6, 3 times 1 is 3. Now I could lay 2 eggs again and then do all those zeros, but I know that this row is going to be nothing but zeros, so I could just add that up. All right, so I have 0, 3, 0, 6, 3. That's not my answer because I have to swoop 5 times. Again, 3 times there, 2 times there, so 5 times. So once, twice, 3 times, 4 times, 5 times, 0.36030. That's your answer. Number 26, just make sure you line it up. So minus 1.3 and then put a 0 right there. 5 minus 0 is 5. 4 minus 3 is 1. Decimal, 3 minus 2 is 2. No borrowing in that case. All the numbers on the bottom are smaller than the numbers on the top. Number 27, it says convert to decimals. So you could do a couple things here. You could actually divide 20 into 12, which you can't do it. So you say decimal, decimal, and then 0. So 20 into 120 goes in there 6 times. That's how you get 0.6. Or you could say, let's do base 10. So times 5 times 5. And this way you'd also get 60 over 100, which is the same thing as 0.60. So 0.60 and 0.6 are the same thing. So either way you want to do it, you can get the answer. You could have also simplified 12 over 20 to 3/5 and said, hey, I know that 3/5 is 0.6. Number 28, always make sure you can't cross cancel, so I cannot cross cancel here. So I just multiply straight across. I get 28 over 15. This is not okay, this is improper. So let's see how many times I get 15 going into 28. It goes in there one time. Oh, sorry, I used the wrong color. It goes in there one time. That's leaving us 13 left over. So sorry, 13 left over. So my answer is 1 and 13 over 15. I cannot simplify it. That's my answer. Okay. Sorry. So 1 came from right there. The 13 came from what was left over. Right. Here I have 2 decimals and 1 decimal, so I know I have to swoop 3 times in the end. So 4 times 4 is 16, put down a 6, carry a 1. 4 times 0 is 0, plus 1 is 1. 4 times 1 is 4. There's nothing, you don't have to lay an egg and do all those zeros, because again, adding a whole bunch of zeros to this is not going to change your answer. So I need to swoop 3 times, 1 time, 2 times, 3 times, 0.4116. And again, I encourage you guys, use a calculator after you've shown work like we just did, and check to see if you have the right answer. And if you don't have 0.416 and the calculator gives you something different, then that's a good sign that you need to go ahead and erase and try again. Obviously, we're going to use KCC on this one because we have subtraction. So we keep this one the same, change, change, and after doing that, it becomes a DSSM. Different signs subtract more. We have more positives than we do negatives, so 6 minus 4 is 2, positive 2. Check to make sure you have the same denominators here. We do, so we can just add up. 2 plus 7 was 9, 1 plus 3 is 4, and keep the denominator. Super simple. 32, hopefully you have memorized. 8 over 10, it's a base 10, so it's just 0.8. How do we prove it mathematically? We say 10 goes into 8. It can't, so decimal, decimal, and add a 0. 10 into 80, 8 times. That's how we prove it mathematically. We could also use base 10. KCC, keep, change, change. Keep, change, change. What does this become? It just becomes an SSAK. Same signs, add, keep. They're both positive. It just becomes 7 plus 16, which is 23. This you could literally do in your head. It's basically just saying, what's half? What's half of 62? So half of 60 is 30. 60, half of 60 is 30. And then half of 2 is 1. So your answer should be 31, right? Now you could do it mathematically by saying times 0.50 and do all that stuff, but I'm just saying you can really just do it in your head. What is half of 62? It's 31. 31 times 2 is 62. A whole bunch of different ways you can prove that. Again, we have a mixed number, so change it to an improper fraction, improper fraction to a mixed number. 5 goes into 22 4 times, and we have only 2 left over. So that's how we get our answer of 4 and 2 over 5. Okay, 4 is our whole number, 2 left over, that's our numerator. Check to make sure you have common denominators here. You do, so then 9 minus 6 is 3, 5 minus 2 is 3, and keep the denominator. All right, last row. Swoop and rewrite. So swoop it once, now rewrite the problem, guys. You now have 2 going into 4, and this is important, decimal, decimal, 2, 4.2. So 2 goes into 4 2 times. Nothing left over, so bring down your 2. 2 goes into 2 1 time. Nothing left over, so you know you're done. 2.1. Creates a KCC. So we keep, change, change. And when we do that, we find out, hey, it's an SSAK problem. Same signs, right? They're both negative. So same signs, add up and keep. And we should get negative 33. Remember to keep the sign. 39. How many times does 40 go into 124? I don't know that off the top of my head, but I do know that if I looked at this as like 4 and 12, I know that 4 goes into 12 3 times, right? So 3 times 40 is 120. I have 4 left over. This is where I add my decimal, decimal, 0. Bring it on down. 40 into 40 goes in there, obviously 1 time, 3.1. Nothing left over, so I know I'm done. All right, remember to flip the second and multiply. So we have 8 over 9 times 8 over 7. Look to cross cancel. You can't, so you get 64 over 63. And when you realize, oh, that's an improper fraction, 63 goes into 64 one time with only 1 left over. So 1 and 1/64. Okay. All right, rewind, watch if you have to, but this is the reference video for level 2.